Hello students, today we are going to obtain common emitter characteristic of NPN transistor. So this is going to be implemented by using LTSpice software. This is the LTSpice software. First of all, you need to go to File, New Schematic, and this screen will appear. Here I need to write the name of my practical. So I will go to Edit, Text, and here I will write my practical name.
So for you to get a BJT, you go to Components, and we are going to work with the NPN transistor. So you type NPN and click on OK. You get an NPN transistor. I am placing this at the center of my page and I click on Escape. Now this has the name NPN over here, but I want to select a particular type of transistor. So I hover over the transistor till I get the symbol of a hand. Right click on it, pick a new transistor, and the transistor that I will be selecting is BC547B. So you've got lots of options. BC547B is normally the transistor that we use physically in the lab as well. So I click on OK and I can see that the name has now changed to BC547B. The next thing that I need is a resistor. I want it to be placed like this, so I rotate it and place it. I want one resistor at the base end as well. Once I place both my resistors, the next component that I will require are two voltage sources. One voltage source at the input side, another voltage source at the output side. And the last component that I require is the ground. So I am placing a single ground and I'll connect all elements to that ground. Once I start making the connections, I am going to connect all the components to each other so we complete our circuit. Just like mentioned in the previous videos, for making these connections you will have to select the pencil symbol and then drag this wire through your entire circuit till you finish making all the connections. One common mistake that people make over here is they directly connect the emitter to the ground, but they forget to connect it to the remaining two parts of the circuits. So you need to see this dot here in between so that it is connected to both the voltage sources as well as to ground. Hover over the resistor, change the value. I am going to make this resistor 2.2 kilo ohms. So that is 2.2K, and this resistor will be 240K. Once you've done this, you will have to give values to your voltage sources. So I am right now giving this a DC value of 0. I am also giving V2 a DC value of 0. Just so that we don't get confused, I am converting this name to VBB because it is a battery connected to the base, and I'll name this as VCC because it's a battery that is connected to the collector terminal. Now, as you know, for getting the input characteristics of a BJT, what you have to do is get a graph of this voltage VBE versus the current IB for different values of voltage VCE. This voltage VCE can be changed by changing VCC. So I am going to plot a graph with VBE on the x-axis, which is the voltage over here, IB on the y-axis for different values of voltage VCE. Now the method for doing this is you go to Run and you go to DC Sweep. The first source that you are going to sweep is VBB, so that you can change the value of VBE. The type of sweep that I'll take is linear. I start at 0 volts, stop at 1 volt, and I'm taking a gap or an increment of 0.01. The second source that I'm going to use is VCC. Type of sweep will remain linear. Start value I'm taking as 0, stop value as 2, and in steps of 0.5. And I click OK to get this statement below my screen, and this is my characteristics that I am going to look at. So I can already see my scale is going from 0 to 1, that is the value of VBB. Now when you come over here to this screen and you get this red color probe, it will give you voltage. So I come here and you can see my probe has now changed, and if I click on this, I have got IB for Q1, that is base current for transistor Q1. And you can actually see only 3 lines. So if I come here and I zoom in, so you can now kind of see that there is one line that has slightly overlapped onto this, but there are 4 different lines for the values of VCE. I'll just go back to the graph. Okay, so since it's not going back, what I'll do is I'll just delete this, and I'll show you another method to add the trace. So you go to add traces and you add IB for Q1 and click on OK. So y'all can see the nature of the graph is exactly like input characteristics of BJT. Now for us to get the output characteristics, let me remove this graph and come back to this circuit. Now for the output characteristics of BJT, I need VCE versus IC for different values of IB. This value of IB changes when I change the value of VBB. So what we are going to do is we go to simulation. Okay, just a minute. Let me show my entire circuit over here. Okay, great. I'll go to simulation, go to edit simulation command, DC sweep. Now your first source is going to be VCC, and say I want to take it from 0 to 15 volts in steps of 0.5 should be good enough. And my second source for changing the value of IB will be VBB. I'll keep the start value as 0. Let me put the stop value as 5, and I'll go in steps of 1. At 0 I won't get any current, but let's keep the start value as 0, and I click on OK. Now I click on run, and you can now see my x axis has changed from 0 to 15 volts. For the y axis, this red probe will give me voltage, so I come here to get current. This is IC of Q1, and the plot that you have got is output characteristic for a common emitter BJT. This green line that you can see over here is because the first value that I selected was 0, so I am not going to get any current over there. And you have got 1, 2, 3, 4, 5 other lines which show you the characteristics for a common emitter BJT configuration. So I hope you've understood how to plot the two graphs.